This is another collaboration with astrophysicist Paul M. Sutter of Ohio State University. This time we're looking at the 10 best and 10 worst places to be in the universe if you're a human. For part 2, check out Paul's channel, link in the end screen and in the description below. Now, without further ado, here are the 10 best places in the universe if you're a human. Number 10. The upper atmosphere of Venus. Venus is a very strange planet. On its face, it looks like the absolutely most awful place you could possibly find in a solar system. It's a hellish environment of sulfuric acid, crushing pressure, and extreme heat from a runaway greenhouse effect. But at the same time, it boasts a layer in its upper atmosphere that is one of the most clement and Earth-like environments in the solar system. So much so that if you lived in a balloon colony suspended in the atmosphere at this level, you could accidentally tear your spacesuit and not die. And in fact, take your time getting back to your colony. This is because within this zone the atmospheric pressure is the same as Earth, meaning you don't get gases leaking in or out as badly from the tear as you would, say, on Mars, where the low atmospheric pressure would suck the air out of your suit very rapidly. This is one of the few places in the solar system other than Earth where this can happen. As a result, Venus is an interesting planet to humans, though currently often overlooked. It has enough resources to be terraformable over a long period of time, and it has that clement area where humans can hypothetically live while that terraforming occurs, though that colony would likely be highly dependent on Earth for centuries. And there is a potential astrobiological technosignature in this one, as we gain the ability to study exoplanet atmospheres and say we see what should be a Venus-like world given its placement in its system close into its star, but instead appears atmospherically to be an unlikely analog of Earth as far as oxygen levels and chemical composition goes. It would need to be considered that someone may have made it that way. Number 9. TRAPPIST-1d.
The search for and the discovery of exoplanets has absolutely exploded in recent years. We know of hundreds upon hundreds already, and we suspect there are many more. As a result of this, we can now say with confidence that planets aren't rare in the Milky Way. But what of planets like Earth? We simply don't have a good understanding of how common our planet is. It could be an exceedingly rare type subject to a very specific circumstance, which increasingly seems to be the case, but there could be others in the galaxy. But so far, we have not seen a twin of this world. But we do have one that may come close, at least we think it is right now. It's a planet in orbit around the red dwarf TRAPPIST-1, and it currently holds the highest score on the Earth Similarity Index out of any other exoplanet. 0.91 out of 1. Study of this planet is ongoing and it could well go down. But as it stands, new data shows that as much as 5% of the makeup of this planet seems to be water, very possibly in liquid form. In other words, it may have oceans. Also, studies with Hubble showed that the planet lacks a thick hydrogen atmosphere, opening up the possibility of a more Earth-like atmosphere. But we know little else. It could be a greenhouse effect atmosphere like Venus or a carbon dioxide one like Mars. But if it turns out similar to Earth and we start seeing odd oxygen and methane levels as ongoing study continues, then life would be on the table as the origin for that.
Number 8. Colonized ice shell moons. When we think of colonizing a planet, we tend to think in terms of habitat domes and eventual terraforming. In other words, recreate on another world the conditions of Earth where we evolved. Key to this is the one thing that we're going to need lots of anywhere we choose to colonize, an ample supply of liquid water. But we are land creatures fundamentally, yet we venture into the oceans with submarines and ships. It also pays to remember that Earth also has water environments that teem with life that, hypothetically, could also be colonized. Realistically, underwater colonies in Earth's oceans would be limited to shallow waters to avoid having to deal with the extreme pressures of the deep, but they are in principle possible with the right technology. Trouble is, there's no reason to do this on Earth. But in thinking about colonizing a body that doesn't have a land environment quite like Earth, rather an ice shell, but does have liquid water oceans beneath, it might be viable to locate such a colony in that ocean rather than at the surface. The obvious candidates for this are the ice shell moons like Europa or Enceladus. While surface colonies likely would end up being more practical on these moons should we ever choose to do it, underwater components could also be useful, especially in regards to harnessing any geothermal energy present at these places. The high pressure in these oceans opens up questions here, but ultimately an ocean environment is at least more familiar to humans than the surface of a frozen Jovian moon. Number 7. Ignorance is bliss.
We live in a time where it is at least possible to largely understand the universe, though we are still very much within the learning curve. But there is a part of our universe so distant that light does not travel fast enough to overcome the rate of expansion of the universe in between. Barring faster than light travel, we will never see this part of the universe, and we don't know how large it is. And it gets worse. As the universe expands, eventually everything becomes so distant from everything else that eventually isolation becomes the rule. As a result, future civilizations may have no way of ever knowing the Big Bang ever occurred, or that there's an entire universe out there. As such, why pay attention to the blackness of space outside of your own galaxy? Future scientists may say that nothing could come of it, and they may well conclude that their galaxy is all that there is, and it might as well be. What exists outside of what you can know or what affects you is meaningless, just as it's meaningless to ask what happened before the Big Bang and the onset of time, if that concept even makes sense. This limited scientific toolkit could leave a human-like future civilization in a kind of blissful ignorance, never able to know that their universe could someday come to an end.
Number 6. Calm SuperEarths. Earth is an amazing world, but it's by no means perfect. At times in its history, it's nearly frozen over, has caused mass extinctions from periods of widespread volcanic activity, frequently features extreme weather, and all manner of other natural disasters. Earth can be a harsh planet, but what of planets that might be a bit calmer? It's possible to envision a world perhaps a bit larger than Earth, in circumstances that may make it possible for it to experience less extreme weather or a lack of ice ages, and perhaps placement in a star system that sees less asteroid impacts and so on. As such, it may be possible that there are worlds out there that are better for humans than Earth is. Oddly though, this may only be true for us humans. Any species native to such a world faces a possible challenge. It may never evolve intelligence. With better, more clement conditions comes less of a need for intelligence. It has been suggested that the general lack of true intelligence in sea life on Earth, most intelligence in the ocean is limited to animals that evolved to go back into the ocean after a period on land, might indicate that oceanic life has it too easy. This may be true for land life on a clement super-Earth. And worse, water itself can become an enemy. On full-on water worlds, where no land exists but very deep oceans do, the conditions of Earth-like life may never arise. Volcanism may never occur on these worlds, for example, and certain gases needed for heating might not get released into the atmosphere, perhaps creating ice shell conditions, where the liquid water is locked up under the ice. Life might exist, but it might also not be able to progress past a certain point. Number 5. Goldilocks Zones.
As the Earth illustrates, where you are located in relation to your star is crucial to the evolution and existence of life as we know it. Known as zones of habitability, or the Goldilocks zone for being just right, they provide a basic framework for what planets Earth-like life and humans can comfortably live on. The first of these zones are the circumstellar habitable zones. This essentially is where Earth lives in our solar system, just the right distance from the sun for liquid water. This zone depends on what type of star a planet orbits, and this zone can be close into the star if it's cool, or far from the star if it's hot. But there is also a galactic habitable zone. This one is more forgiving in that a large part of the stars in our galaxy is within it. But certain areas such as the center of the galaxy or inside a dense star cluster probably would not host planets where humans could easily live, if at all. The reason for this is that you're simply too close to other stars and subject to their radiation and nearby supernovas. At the furthest reaches of the galaxy, you don't have that problem. But that far out presents other issues that may make it uncomfortable for humans, such as a scarcity of raw materials. Of course, habitable zones are subject to exceptions, such as the ice shell moons like Europa, and with technology, humans could live far outside these zones, but as a matter of the best places in the universe for humans, the habitable zones provide the best starting conditions.
Number 4. Virtual realities. While it could be said that some basic, clement environment is needed for human life, that equation may change in the future when humans are able to alter our own biology or abandon it entirely. There, the rules change. For machine life that was once human, a broad variety of environments open up, including that of deep space. In fact, if the speed of the calculations being performed by a formerly human computer are a concern, the colder the environment, the better. But would humans as technological beings even care about what their actual physical environment is like? Would Earth still matter? We don't know yet, but it may be that the best environment for a technological human is a total virtual reality that's superior to anything that exists in the real universe. Why pay attention to this universe when a digital utopia can be created that better suits the human condition? So here the concerns for where we would be most comfortable depend more on efficient calculation and massive energy production to keep it all going, rather than the concerns of suitable atmospheres and warmth. Number 3. Improved Earth.
One of the things that advancing technology allows us is greater control of the circumstances Earth finds itself in within the solar system. Ultimately, we will be able to essentially improve Earth by gaining greater control over certain risks, such as that posed by asteroid impacts. In the past, Earth was not nearly as clement as it is today, and in fact, early in its history could not support life at all, and was subject to constant bombardment. Asteroid impacts can still happen, and with technology we can deflect or even destroy problematic asteroids. But in the future, Earth will eventually become uninhabitable again, but not necessarily so if we develop technologies to literally move Earth, or move somewhere else, as the sun brightens and eventually becomes a red giant. This is not as far-fetched as it might sound. By orchestrating asteroids to pass by Earth and provide a small but non-zero gravitational tug on the planet, over very long periods of time, on order of hundreds of thousands or even millions of years, the planet could be migrated to wherever we want. So to some degree, we could, hypothetically, improve our world by giving it longer life in a changing solar system, or protect it by mitigating planetary risks like asteroids, or even building orbital sunshades to mitigate its growing luminosity.
Number 2. Better than Earth. Earth is a wonderful world located in an amazing solar system that all happen to allow conditions that have resulted in the rise of life, intelligence, and a civilization. In a way, human civilization, for all its faults, is still an encouraging indication that other civilizations could exist in the universe. And often we imagine them as being more advanced or more enlightened than we are. That may or may not be true, but Earth is not necessarily perfect. While it has the conditions conducive to the development of intelligent life, it can also be subject to conditions that might cause intelligent life to go extinct, such as the aging and eventual death of the sun, or asteroid and comet impacts. But in the end, if we stay in this solar system, the conditions of it will, long-term, likely force us to look elsewhere for habitable worlds. And while nothing in this universe is going to be perfect, including the universe itself, which will eventually become inhospitable to life in its own right, there are some cases where we might find worlds better than Earth that could remain habitable for far longer of a period than this planet could. One factor would be stellar types. The Sun is a Type G yellow dwarf that will eventually expand into a red giant and finally settle down to be a white dwarf. While there are hypothetical ways to keep Earth, or at least some body in the solar system, habitable during all three phases, it might be better to just inhabit another star system entirely that will remain stable far longer than this one will. This includes the Type K orange dwarfs and Type M red dwarfs, both of which live far longer than our star, and they are happily far more numerous than any other kinds of stars in the Milky Way. So, as far as long-term human survival is concerned, there may be worlds located in perfect sweet spots within the habitability zones of mature red dwarfs and orange dwarfs that might yield planets better than Earth if we as humans tweak them with terraforming. Number 1. Artificial worlds and habitats. The case can be made that only humans know what's perfect for us. Our own planet can, at times, become unpleasant or even uninhabitable, but being human, we can also envision technologies that would allow us to alter a planet's climate, or even create a completely artificial environment that maintains ideal conditions for human life. We already do this to some degree with air conditioning and heating, but on a planetary or even larger scale, we could do this with far larger amounts of space than we have here on Earth. The first such option would be a terraformed world, a natural planet that we have used terraforming techniques to alter to make for a better environment. But that's not the only option. It's also hypothetically possible to build megastructures and even artificial planets that can be inhabited by humans and maintain a perfect environment for us. These include Dyson spheres around other stars, or partial variants of that idea, such as Larry Niven's ring world, but also enclosed rotating habitats, such as O'Neill cylinders, that make use of centrifugal force to produce the effect of artificial gravity. Such an environment could be perfect for long-term human habitation. Thanks for listening. I am John Michael Gaudier.
And I'm Paul Sutter, and I hope you enjoyed this collaboration.
And be sure to subscribe to our channels for regular in-depth explorations of science, astrophysics, and this amazing universe in which we live.